All right, so for our notes, we're going to add on to our log section here. So why don't you guys open that up? What we were working on before, and I know it's been a while, so just to go back over where we were, we had these rules of logs. This was the last thing that we did. We had 3 different rules. The addition rule, where we were condensing, addition, subtraction, and the power rule for logs. All right, so for today, we're going to be solving some exponential equations, okay? All right, so, and we're going to have to use logs to do that. So let me label this logs to solve exponential equations. Sorry about my bad handwriting there. And so here's why we might need to use logs. When you guys walked in today, if I said, okay, I'm going to erase this, so you don't need to write this down. If I said, all right, guys, 2 to the x equals 8. Okay, most of you could come up with the fact that x equals 3 because 2 to the 3rd equals 8. And if I said, all right, well, how about 2 to the y equals 32? Most of you can come up with the fact that y equals 5 because 2 to the 5th equals 32. But those are easy problems, like in the sense that I gave you nice numbers. This one would not be as nice. So this, maybe you do want to write. So I'm going to figure out 2 to what power is equal to 100. Okay, and the answer is not 50, of course. Right? So like 2 to the 5th is 32. 2 to the 6th is 32 times 2 would be 64, right? 2 to the 7th would be 64 times 2 would be 128. So it's somewhere between there, but I don't know exactly. So this problem is difficult to solve in this exponential form. But what we could do is, because we learned through our code that we just did, we could put this into log form. Remember, when we do that, that would be that x equals log base 2 of 100. So you see where that skill is important. And I know that this looks weird to you guys. That's a number. We're just not used to that kind of number. Okay, it's an exact number, and I'm going to show you how to get an approximate number in just a second. And when you write that, by the way, just to refresh your memory, all of this stuff, the LOG, the 100, those are all written the same size and on the same line. And the 2 is a subscript. So the 2 is written smaller and below. Okay, so and if we would speak that, say log base 2 of 100. Let's get a decimal approximation of that. So I'm going to go to my calculator. There it is. All right, so we're going to go to our calculator and I'm going to go to log base 2 of 100. Remember, on the graphic calculator, if you're using the app, you have to click and hold the enter button down. If you're doing a handheld, you don't have to do that. You have to hit control enter. But I want to get that. Come on. There it is. So it's about 6.64, which is what we thought. Remember, we said it was between 6 and 7. Okay, so x is approximately 6.64.
I have a question.
Yeah.
How do you put the log on the handheld?
On the handheld?
Yeah.
Let me see here. So, all right, I'm gonna have to, let me go back here. And I gotta change up. All right, are you able to see my screen?
No.
No, okay, so give me just a second then, please. All right, how about now?
Yeah.
We're good? Okay, so on the handheld, our log button is written here in blue above the 10 to the X. So I'm gonna hit Control, log, and base 2 of 100. And then remember, I have to hit Control Enter on the handheld. Okay. Any other questions before I change back to the other screen? All right, you guys are all good there. So let me get back, pull up my notes here. Sorry, this is not as quick as it used to be with the iPads, but we still get there. All right, so let's do another one, okay? So that was one that was, I would say fairly straightforward, but they're gonna get a little bit more intense. So let's say that we had, how about 5 to the 3x minus 1 is equal to 413. So ugly looking problem, but really this is why we make calculators, right? We're gonna put this into log form. We use our calculator to solve it. So first thing I would do is put it into log form. So I'm gonna write 3x minus 1 is equal to log base 5 of 413. And I'm gonna leave it in this exact form. I have to self-rest. So I have to add 1 to the other side and divide by 3 on the other side. So my answer is going to be x is equal to 1 plus log base 5 of 413, all divided by 3. And that ugly looking mess is our exact answer. And we need to write it that way because like this part is irrational. But I am going to find a decimal approximation of this also. And notice that I wrote the 1 out in front. You can write it back over here. I just typically don't do that because I don't want to make the mistake of finding log base 5 of like 414. It doesn't work that way. Okay, these are 2 separate things up top. This and this need to be done separately. So I have 1 plus log base 5 of 413 divided by 3. So let's go to here. Got my fraction. 1 plus log base 5 of, was it 413? Is that right? Okay. And what was it divided by? Divided by 3. Thank you. I'm glad you guys have better memory than I do. All right, and there we go, 1.58. All right, so far so good. All right, well, there is also a formula that's used quite a bit with money that you may or may not have seen before. So I'm gonna write it down and then just let you take a look at it. So let's see, A equals, well, you guys probably should write this down, although it's given to you in your delta math. So if you don't want to, it's A equals P times 1 plus R over N divided by N times T. And this is usually used for money, finding out how much money we have in a certain account. Okay, and in this, let me tell you what the different variables stand for. So A is the final amount. P is the initial amount. Stands typically for principal, which means your principal amount or initial amount. R is your rate. T is time. And N is the number of times your interest is compounded. I'll explain that in just a second. I'm gonna write down and I'll explain. N is the number of times compounded. All right, so for example, let's say you have a, let's say you invest $1,000 into an account, okay? You got $1,000, you put it into an account and you invest it wisely and you're making 8% interest. Or perhaps you buy a treasury note, or you buy a CD, or so you're earning 8%. But the number of times it's compounded quarterly. What that means is it doesn't mean you get 8% each quarter. It means you get a fourth of 8% every quarter. So in this, you don't really, the equation accounts for this, but what happens is you actually, after the first quarter of the year, meaning 3 months, you get 2% after the first quarter, then 2% over the next quarter, 2% over the next quarter, 2% over the next quarter. So you're earning 8% annually, but it's compounded 4 times. And that actually is advantageous to you because you then are earning interest upon your interest. So you're making more money the more often it is compounded. So in this particular scenario that I'm talking about, we started with $1,000. And I'm going to do 1 plus a rate of 8%. So that is written as 0.08. And it's compounded quarterly. So that is going to be 4. That means 4 times a year. If it was compounded monthly, that would be 12. If it was compounded daily, that would be 365. Okay. So it's compounded quarterly. And let's see how much this is worth in, I don't know, 12 years. Okay. So I'm just using this formula again here. My N is 4 and my T is 12. That is going to give us our final amount. So now if we just want to figure this out, I'm going to plug that into my calculator. So there we go. All right, I've got my initial investment of $1,000. And I'm going to multiply that times 1 plus, I'm going to make a fraction here. My top is 0.08. My bottom is 4 because I'm compounding it quarterly. And then don't forget it is an exponent of 4 times 12 years. So that's the way it looks in your calculator. Are we okay so far before I hit enter? You guys are all good? Okay. And so there we go. It's now worth $2,587.07. And we want to round it accordingly, which it does right now anyways. So, and 7 cents. So just by letting our money sit there and not doing anything, it's earning interest. It is more, we have more than doubled our money in that case. All right, any questions on that? All right, we're good. Anybody at home? Please feel free to shout them out.